So let's take a look and use this command to its full effect, playing around with the different syntax that we have now seen with and without wildcard masking. So I'm going to validate that I don't have any routing protocols turned on. I'm going to look at my interfaces with a show IP interface brief, and then we can get going. I'll do a router EIGRP 100 to turn on EIGRP. Then I'll do a network statement. And I'll say I want to run EIGRP on all interfaces in the 10.1 space, wildcarding out the latter 2 octets. And I'm satisfied. I'm not going to run on my loopback interface. That loopback interface may be for controlling other protocols. So I'm satisfied with that. I'm going to do the exact same thing on router 2. I'm going to rely on my topology table, make it a little bit bigger if you want to look that over as I type. I'm getting some adjacencies, that looks good. Going to move on to R3. Now I'm going to use on R3 a classful version of the command, network 10. Ooh, is it still going to work? Yeah. It's just going to now open up that network statement to apply and wildcard out the 2nd, 3rd, and 4th octets. Now here, it's not how I wanted to do it. I want to do a show IP interface brief. I want to run EIGRP, maybe just that one interface in the network space of 10, and I'll run EIGRP on 172.16.33. See, I'm just making sure that I'm capturing the right interfaces. So that's router 4. Now I'm not going to run on my connection to the internet, which is Fast Ethernet 3. Not going to run on my connection to the internet. I like having a topology table, but I'm going to rely on my show output. Okay, now I want to show you something else. I can get creative. Not like I would do this in the real world, but if I want to have, let's say, a 23-bit wildcard mask, 23 zeros, 9 ones, what that command would do is it would specify the range of 32 to 33. How can you interpret that? Well, the IP address specified is the beginning of the range, and then sum the two together to get the ending of the range. Add the wildcard mask to view the end of the range, and yeah, that'll work for any wildcard mask that is properly formed, okay? And I'm done here, actually. This would be a little closer to how we do it in the real world. Specifying maybe a 24-bit wildcard mask. There's nothing wrong with however you choose to do it, so long as you are sure to include the interfaces that need to be in and exclude those that need to be out. That's what matters. So that looks pretty good. R6 is done. Moving on to R7. And for grins, we'll do something totally different. I'll do a network of all zeros and a wildcard mask of all 255s. I would not do that in the real world, but that says run EIGRP on every IP address that could possibly happen on this router, every interface that's up, just to see some of the extremes to really gain mastery of this. So, how do I view my network statements? That's one last part of this. If I want to view my network statements, I can do that with Show IP Protocols. That section right there, Show IP Protocols. That section right there shows me my network statements. And I think I got a little bit more creative on R4. So in R4, again, shows me my network statements. And those are a match to the wildcard masks that we put in. An all zeros wildcard mask for the 10 network, and that specific IP address in the 10 network. 3 zeros and a 255 for the 172.16. Now don't misread this. This does not say we're using those as the subnet masks that we will advertise. If I were to look at R1, for instance, are we going to see unusual masks that differ from what we have in the topology? No. Do a show IP route EIGRP, and let's look at the 10.134 network. That should be advertised as a /24, and we can see that it is. So again, the network command does not control the mask that is advertised. Understanding this network command, and also how, if we omit the wildcard mask, one will be given to us. Knowing those things is really important so that we can read these and properly form them when we enter them into our routers.